Mustang Manufacturing has been designing and building squeeze tools for over 50 years. The tools have always been designed with your personal safety as the primary concern and meet or exceed the requirements described in the ASTM F1563 standard for squeeze tools. Additionally, the ASTM F1041 standard should be consulted for recommendations and industry standards for the actual squeeze process. The intent of this video is to describe the correct procedure for safely squeezing off polyethylene pipe using a Mustang squeeze tool. Your company has developed safety procedures to protect both you and the surrounding area. Always follow these procedures, and if you have any questions or concerns, ask first. Mustang offers both mechanical and hydraulically operated tools, and while the means of applying the force may be different, the actual squeeze-off procedures are almost identical. Tool inspection. Before using the squeeze tool, you should take a few minutes to familiarize yourself with its basic design and function. Mustang tools are designed to withstand many years of hard use, but performing a quick inspection prior to use is always recommended. Look for any bent or damaged parts. On mechanical tools, over-torquing is the primary cause of the tools not performing as intended. A bent handle, pipe wrench marks on the head of the power screw, or crushed gap stops are all indications that the tool has been over-torqued at some point, and further inspection may be required. The power screw should turn without resistance, and the upper jaw should slide up and down without binding. The upper jaw is designed to float to accommodate pipe that is out of round or slightly off-center. If the jaw is tight or locked up, the tool should not be used until repaired. The lower jaw should also be examined for damaged or missing gap stops. Mustang recommends that any squeeze tool have a proper static grounding device attached prior to use. The SEG30 grounding kit is offered as an option and adapts to any Mustang tool. It is intended to be installed on the upper jaw bearing block with a provided adapter. On mechanical tools, the grease fitting is removed, the adapter installed, and the grease fitting reinstalled into the adapter to allow for lubrication of the thrust bearing. Installation on hydraulic tools is identical, with the exception of the grease fitting, which is not required. Choosing an appropriate squeeze-off point. When you arrive at the site, determine a safe location to perform the squeeze-off. The general rule is that a squeeze-off should be at least 3 pipe diameters, or 12 inches, whichever is greater, away from any fusion joint, fitting, or previous squeeze-off area. Examine the pipe and determine diameter and wall thickness which is printed on the pipe surface. If the print is unreadable or you have any doubt as to the size of the pipe, be sure to check with your supervisor. Choosing the appropriate gap stop. After determining where you will make the squeeze-off and what size pipe you are working with, you must select the appropriate gap stop. Steel gap stops are welded to the top of the lower jaw, so you cannot accidentally over-squeeze and possibly damage the pipe. Pipe sizes have been printed on these red end caps and stamped on the top surface of the gap stop. Gap stops are sized for specific pipe wall thicknesses, and it is sometimes possible to combine several sizes on one stop if they share the same wall thickness. Also, there can be several different wall thicknesses for the same OD size pipe, so just because a tool has a capacity of 8-inch, for example, doesn't mean it can do all 8-inch pipe. This can sometimes get confusing, and it's best to consult your Mustang distributor or Mustang directly if you have any questions. The key point to remember about gap stops is that they are based on pipe wall thickness and are there solely to protect the pipe from being over-squeezed. Grounding the squeeze tool. Manual tools. PE pipe has many advantages over other pipe materials, but has one characteristic that may differ. Polyethylene is non-conductive and can allow a generated static electric charge to build up. If ignored, this charge could seek a path to ground, and in doing so could create a spark. It is important to remember that a static charge could be generated on both the outside and inside of the pipe. Burlap soaked in a soapy water solution is one method that is commonly used to mitigate any static charge on the exterior of the pipe. After wetting the surrounding area, the burlap is wrapped around the pipe and then placed in firm contact with the wetted ground. Suitably grounding the squeeze tool itself can provide a safe path to ground for an internal charge generated at the squeeze-off area. Before you bring the squeeze tool anywhere near the pipe, be sure that you have already wet down the ground around the pipe and that you have positively attached a grounding kit to the tool. Drive the copper spike firmly into the ground so that the squeeze tool is well grounded, and if a static discharge does occur, the voltage passes through the tool to the ground and not through you. Making your squeeze. Manual tools. With the soil wet, the pipe wrapped in burlap, and the grounding cable attached to the squeeze tool, you are now ready to make your squeeze. Make certain that the squeeze area is free of any debris that may be pressed into the pipe surface during the squeeze. First, raise the upper jaw so it will fit over the pipe. We have determined that our pipe size is 2 inches IPS SDR 11. Unpin and slide the bottom bar out. Next, select the proper gap stop by reading the pipe size that is printed on the red end caps. Pipe sizes are also stamped on the top surface of the gap stop. Here is the 2-inch IPS stop. Note the direction of the arrow. When installed, this arrow must point up toward the pipe. Remember, arrow up is always the correct orientation. Now, place the squeeze tool over the top of the pipe. With the 2-inch pipe arrow in the up position, we slide the bar all the way under the pipe and into the opening on the other side of the squeeze tool. Make sure this crossbar is against the tool frame. If it's left out like this, the gap stops are not aligned. You should also reinsert the cotter pin to help keep the lower jaw from sliding back out of the frame. Now, return the squeeze tool to a centered position over the pipe. To achieve a satisfactory squeeze, it is important that the pipe be positioned dead center and squared in the tool. Use the center of the power screw and the grease fitting to sight down the tool to the center of the pipe. Square the squeeze tool to the pipe center line. Slowly turn the handle on the squeeze tool, moving the upper jaw down onto the pipe. The rate at which you squeeze the pipe is very important. A squeeze rate of 1 minute per diameter inch of pipe, for example, 2 minutes for a 2-inch pipe, is conservative and easy to remember. Squeezing too fast can result in damage to the pipe. PE is a ductile material, so recheck the tool to make sure it's still centered on the pipe. If the squeeze jaws are not parallel, then the tool is not centered. If this condition occurs, stop. Back the squeeze tool off the pipe, recenter the tool, and begin again. Slowly continue to turn the handle until the tool is reasonably tight. Now you should wait a few minutes to allow for cold flow of the polyethylene. Again, figure on 1 minute for each diameter of pipe you're squeezing. In extremely cold weather, this cold flow redistribution may take twice as long to complete. After the pipe is relaxed, you could again tighten the tool approximately a quarter turn. At this point, the pipe should be squeezed off sufficiently to allow work or repair to begin. It is important to note that you may not have to go all the way down to the stops to achieve a satisfactory squeeze-off. Many factors contribute to a successful squeeze. Temperature, pipe condition, and type can have a significant effect on squeezing. While rare, it is possible that you may not achieve a complete bubble-tight shutoff. Over the years, companies have adopted procedures to deal with the occasional blow-by, and many of these have become common practice for both gas utilities and contractors. If you are having trouble achieving a satisfactory squeeze-off, check with your company to see what procedure they may have approved. Releasing the squeeze. Manual tools. When work is completed, you're ready to release the pipe, but be cautious that you release the squeeze slowly, about a 1/2 inch per minute of release. Again, consult your company's safety procedures for the controlled release rate for the pipe being used. Once the tool is free and no longer has a grip on the pipe, you may reverse the procedure. Unpin the bottom bar. Slowly slide the bar out of the squeeze tool and lift the squeeze tool off the pipe, keeping the grounding cable attached until the tool is entirely removed from contact with the pipe. Now you should clearly mark the pipe at the point where the squeeze was made. In the future, if the pipe were to be squeezed again at this point, it might cause pipe damage. The pipe will soon return to its near normal size under pressure. Hydraulically operated tools. Let's turn our attention to the hydraulically operated tools. First, we'll review the features of Mustang's hydraulic tools and how they may be different from other hydraulic tools you may have used, as we manufacture our own cylinders and hand pumps. Mustang uses what are known as double-acting cylinders. That means the cylinders must be pumped both down and back up. This gives you much more control of the release than a single-acting cylinder, where a spring returns the ram and you must control the release by adjusting a valve. Mustang hydraulic tools operate at a medium pressure of 3,750 psi. Many off-the-shelf tools operate at up to 10,000 psi, which allows them to use smaller and lighter components. That's a lot of pressure, and although the components are designed to operate at these pressures, they are often doing so at their maximum rating. Mustang cylinders are larger and thus heavier, but given the extreme conditions that these tools are often subjected to, we feel the weight penalty is a small price to pay. Another safety feature that is unique to a Mustang cylinder is an internal safety locking valve. This valve is located inside the head cap on a single-cylinder tool and in a common manifold on multi-cylinder tools. The purpose of the valve is to lock the pressure in the cylinder so it will not release in the event of a sudden loss of pressure. This valve operates automatically with no operator input, and in the extremely unlikely event it fails, it won't prohibit the tool from still working. It just won't lock. Hand pumps. Moving on to the hand pump. Mustang makes its own hand pumps as well, again with the operator in mind. All the critical components of the pump, check valves, relief valve, are accessible for maintenance if required. Mustang pumps are unique in another important area. They are two-speed pumps but have separate pistons for the high and low pressure sides. The operator must move the handle from low pressure, high volume to high pressure, low volume to complete a squeeze. The hoses we use are non-conductive, meaning they have no metal braiding inside and have a 5,000 psi working pressure rating. The hoses are an important part of the complete package and should be replaced if cuts or kinks are apparent. The quick disconnect. Now let's look at one of the few components Mustang does not manufacture, and that is what connects the pump to the tool, the quick disconnect. Quick disconnects are very simple components that are widely used on all sorts of hydraulic equipment, but not paying attention to them can create some headaches. It is critical that the couplings be connected properly, with the threaded collar on the female fitting screwed all the way down and contacting the shoulder on the male fitting. Failure to do this could result in blocked oil flow and a tool that locks up. If this should happen to you, the following procedure may be used. Never attempt to loosen or remove any components from the hydraulic cylinder while under pressure. Make sure the saddle clamps are installed and are properly torqued. Start by relieving the pump pressure by moving the pump control valve from down to up several times. The gauge should read 0. Disconnect the quick disconnects at the tool. Using something soft, such as a wooden hammer handle, tap the exposed steel ball on the male quick disconnect until the ball moves freely with your thumb. Some oil will come out, so try to have a rag or something handy. Repeat the procedure on the female disconnect using a 1/2-inch socket extension to fit into the cavity. Reconnect the pump and make sure the threaded collars are connected properly. This procedure should not be considered a standard procedure and should only be used as a last resort. Squeeze-off procedure, hydraulic tools, safety check. Preparation for using these tools is similar to the procedures used with the mechanical squeeze tools. Examine the tool before use to be certain that it's in a good working order and does not have any obvious damage. It's best to check out the pump and tool separately so any problem can be easily isolated. The ground in the pipe needs to be wet down so the area is well grounded. Wet burlap should be wrapped around the pipe just like we showed you before. First, the pump. Unscrew the red filler plug on top of the reservoir and check the oil level. It should be within 1/4 to 1/2 inch from the top. There are 2 hex plugs located on the filler block. One serves as a vent for the reservoir, and the other provides overpressurization protection. We use AW32 hydraulic oil, which is very common, but if you don't have any, you may substitute a different weight hydraulic oil. Use only petroleum-based hydraulic fluid, no synthetic, and never brake fluid or ATF. Replace the oil filler cap. Check the gauge and other pump components for signs of damage. Remember to check hoses for cuts, crimps, or evidence of abuse. Clean both quick disconnects and couple them together. Make certain that the threaded collar is tightened against the raised metal shoulder. Now place this control valve in the down position. Using either piston, pump the handle for about 30 seconds to purge any air from the system. Next, move the control valve to the up position, and again, pump the handle several cycles to purge any air from the system. Now, loosen the threaded collar 3 turns and pull on the hose connectors to disengage the coupler. Move the control lever back to the down position, and using the small piston, turtle, pump the handle until the pressure gauge reads 3,750 psi, the top of the green arc. Check to make sure there are no pump or hose leaks. If the pump makes and holds pressure, it's ready for use. Move the control lever to the up position to relieve the pressure. Make sure the pressure gauge reads 0 before you attempt to connect the pump to the tool. Now, let's check the integrity of the squeeze tool. It's important to first remove the lower jaw before attaching the pump. This will prevent possible damage to the lower bar during testing. At the top of the cylinder, make sure the quick disconnects are clean. Here's a quick tip that will help with assuring the proper connection of the quick disconnects. Place a rag over the male connector on the tool and press down on the steel ball several times. The ball should move freely, and a little oil may seep out, but this will assure you that no pressure is behind the ball. Now connect the hose couplings coming from the pump to the tool, making sure the connectors are fully engaged. We can't say that enough. Move the pump control lever to the down position. Pump the cylinder down until the upper jaw has traveled all the way down to the bottom. Use the large piston marked with an orange color band and rabbit image until the pump begins to build pressure, about 1,000 psi. Then, move the handle to the other piston marked with the green turtle image and pressurize to 3,750 psi. Do not try to use the large rabbit piston to do all the work, pressurizing to 3,750 psi. It will be very difficult to pump and could damage the pump linkage. This process will purge any air that may be in the cylinder. Move the pump control lever to the opposite side and pump the handle to release the locking valve as discussed earlier. It may take several strokes, but you should feel the valve release. Continue pumping until you raise the upper jaw all the way back up to the top. Move the control lever on the pump back and forth from up to down several times to make sure there is no pressure still in the cylinder. This completes the tool cylinder safety check and you are now ready to squeeze the pipe. Squeeze-off procedure, hydraulic tools. Performing the squeeze. Again, use the same procedures as before for static electric grounding. Connect the pump to the tool as described before. Select the proper gap stop that conforms to the pipe size. For this demonstration, we're using a 6-inch pipe. Remember to push the lower jaw all the way in so the crossbar is up against the frame like before. Center the tool over the pipe and follow the same centering alignment procedures as before. If the pipe is off-centered, you may not achieve a complete squeeze-off. Now we're ready to squeeze the pipe with the grounded tool. Move the pump control lever to the down position and begin pumping using the rabbit piston. After achieving a partial squeeze-off, again check your pipe centering. The upper squeeze jaw must be level and parallel to the lower jaw. Continue pumping using the large piston until the pumping effort increases and the pressure on the gauge reads about 1,000 psi. Move the handle to the turtle piston and continue pumping until the gauge achieves a 3,750 psi reading at the top of the green arc. Again, do not try to do the entire squeeze using only the large piston. Damage to the pump may result. Now, you should wait about 1 minute for each diameter inch of the pipe for the cold flow redistribution. Remember that cold temperatures will require a longer waiting period. Cold flow redistribution can be verified by a drop on the pressure gauge. Do not exceed a squeeze rate of approximately 1 minute per diameter inch. It should take about 6 minutes to complete the squeeze-off on a 6-inch diameter pipe. Do not try to hurry the process. As you wait for the pipe relaxation, this is a good time to get out the Mustang saddle clamps and attach them to the tool. The saddle clamps are required safety components that mechanically lock the upper and lower jaw, preventing the tool from releasing if hydraulic pressure is lost. The design of the Mustang saddle clamps provides a bonus feature. As they are positioned over the ears of the squeeze, torquing them evenly down helps seal the area where any leakage may typically be greater. Once the pipe is relaxed, recharge the cylinder back to 3,750 psi. Now, torque down your saddle clamps evenly until the hydraulic pressure gauge drops off 150 to 200 psi. This drop in pressure means that saddle clamps have mechanically overridden the squeeze force of the hydraulic cylinder. The pipe squeeze-off is now complete. When work is completed, you're ready to relieve the squeeze force, allowing gas to pass back into the pipe. As before, a controlled release rate is important. 1/2 inch per minute is the recommendation. Loosen, but do not remove the saddle clamp nuts. Move the pump control lever to the up position and pump approximately 8 full strokes. This releases the locking valve. A slow release of pressure on the pipe can be achieved by gradual release of the saddle clamps. Once the initial release is complete, you can entirely remove the saddle clamps. Continue to slowly retract the jaw from the pipe until it is clear. You can now proceed to pump the upper jaw back up off the pipe. Remove the tool from the pipe, keeping that static discharge device attached to the tool and firmly planted in the ground. Once again, mark the squeeze area so nobody squeezes that section again in the future. Thank you for taking the time to watch this video. Mustang will begin attaching a QR code on all its tools to allow you to access this video from anywhere via your smartphone. And as always, the Mustang tip cards which summarize the basic steps to a successful squeeze-off are still available. If you still have any questions or concerns, please feel free to contact your Mustang distributor or Mustang Manufacturing directly.